So this is yesterday's, right?
Okay, sir.
Yeah.
Maybe yesterday.
This is yesterday's. So what is your doubt?
So can we prove this with Archimedean principle and not by if there's not mentioned in the exam in the question that we have to prove it by Sandwich theorem, so can we prove it by Archimedean principle?
Prove by Archimedean's principle, then it's fine. Otherwise, you have to use some other tools, right? It's not like that everything can be proved by Archimedean property.
Yes, sir.
So when there is some n natural number greater than real number, if these kind of things are needed, then you can prove it using Archimedean property. Like limit n tends to infinity 1 by n 0, limit n tends to infinity. Suppose n square plus 1 by n square 1, right?
Yes, sir.
So these kind of things you can prove using Archimedean property, right? That using the epsilon n, whenever you have to prove using epsilon n definition, there you have to use most of the time Archimedean property, because there will be always, suppose limit n tends to infinity n, suppose this sequence where it will goes. So this is a divergent sequence, unbounded sequence you have checked, right, yesterday. So there also you can prove that for any real number alpha, so this will hold, right? Like n greater than alpha by 2. Is not it? Suppose we'll get some one natural number. So for n greater equals to n, what will happen? This will be alpha by 2. So n greater than alpha. Lathong, don't talk.
और सर ये वाला जो क्वेश्चन है x की पावर 1/n वाला,
So if you suppose in exam given that to prove using algebra of limits, or by definition. So either by epsilon in definition or algebra of limits. On it, suppose thing is mentioned, then you can use any of. What do you think?
ओके सर। ये वाला जो क्वेश्चन है x की पावर 1/n वाला, सर एक बार आप उसको फिर से थोड़ा सा एक्सप्लेन कर देंगे मेरे को? वो 1 + dn वाला कॉन्सेप्ट समझ नहीं आया कि वो क्यों मतलब
अच्छा,
अप्लाई किया।
तो तुम लोगों को क्या बोला था कि यू हैव टू कंसीडर केस वाइज, राइट?
सर
सपोज 0 less than x less than 1, x greater than 1, and x equals to 1. So these three cases will cover this one, right? So x greater than 0, so we have divided into three parts: x greater than 1, 0 less than x less than 1, and x equals to 1. Is it clear?
Yes, sir.
So for x equals to 1, you know the sequence limit will be 1, right? Limit tends to infinity 1 to the power 1 by n. That will be your 1, right?
Yes, sir.
Now suppose this case x greater than 1. So already before that you have already proved what? That if suppose something is less than greater than 1, suppose 1 by mod x greater than 1 in the previous example, then you have written that 1 plus some numbers, right? Some positive number you have write. Similarly here also we have seen that if x greater than 1, then what will happen to x to the power 1 by n? If x is greater than 1, case 1 suppose, if x is greater than 1, then what will happen to x to the power 1 by n? It will be greater than 1 for every n.
Yes, sir.
For all n greater equals to 1, right? So now if some number depends on n, this one, and it greater than 1, okay, so you can write some number I have written depends on n. Dn is positive. Is it clear?
Yes,
So
sir.
for each n, this is for each n. For each n x to the power 1 by n greater than 1. So now we are writing, since you greater than 1 plus some numbers. So I have given some notation dn, so that you have to understand that this depends on also on the n, right? So that it varies like for each n, because we don't know, suppose it will vary, right? 1 point something, then for other for n equals to 5, suppose this number will be 1.25, suppose like that, right? So it will be vary. So for each n it is dn is varies, right? So dn is strictly positive, that we have considered. But in last example, there this n does not vary, so I have taken some fixed number a. Can you remember that in some other example we have considered this one?
Yes, sir.
Because here nothing is depends on n in this stage,
Hmm.
so we have taken. But here you can see that this depends on n, right? For each varies, we have taken dn, and dn is taken as positive number. Then you are doing as usual. So now, whether limit tends to infinity, we talking Vaishnavi. So now you have to use algebra of limits, right? That this sequence will converge to the limit of this sequence plus this constant one, right? Is it clear now? X to the power n
Yes,
plus
sir.
y to the power n will converges to what? So we have already know, suppose this xn converges to x. Now if we can show that this yn converges to some y, then there's sum of the sequence will converge to the x plus y. That we know from the algebra of limits. So this is one is constant sequence. Okay. So we know that it converges. Now we have to check where dn converges, right? So to prove that where dn converges, we have used here binomial rules, right? And then we have done something. What we have done here? So x equals to 1 plus dn to the power n, right? 1 plus n dn plus to
Okay, sir. Okay.
dn
Got
to
it.
the power n. So now you want something, so that we have to see where dn goes. Then we can use algebra of limits. So where dn will goes, how will know? So this all this term, so is greater than n dn. Is it
Yes, sir.
is it clear?
Yes.
Ah. So you, if somebody can write this one, then we have to see whether this is whatever you want to prove, whether this can be proved. Someone can write this one, right? So in various problems you have to see. So both, okay, various problem you will see different kind of things. Suppose maybe you will see in some other problem that you have to consider the second, third term here. Particular type of sequence are there. So you have, that's why you have to solve various exercise. Okay. Now it's clear.
Yes, sir.
So suppose then you will see that dn will be less than x minus 1 by n. And dn, so and you will know what this sequence will converge. So since x greater than 1 here in this case, so this is positive number and some constant into 1 by n. So this sequence will goes to 0. So by Sandwich theorem, dn will goes to 0. So your limit tends to infinity, x to the 1 by n is equals to 1 when x is greater than 1. Similarly, you have to prove what will happen in 0 less than x less than 1 case. Okay.
Okay, sir.
Okay, so any other doubt? Any other doubt till now? Please ask if you have any doubt. Okay. So you have any doubt regarding upper bound? Suppose some sequence xn is there. Okay, and suppose its least upper bound is m, then what will get? What should we get? Suppose xn is a sequence, okay, and m is least upper bound. What do you mean by that? Someone just, can you give some hint if you have understood properly? This we already have studied in the case of real number, right? That a subset of the real number s is there. This is already have studied, right? Then this, suppose m is supremum of that set, then what do we mean by that? Suppose small m is infimum of that set, then what do we mean by that? Suppose this infimum and supremum is attained, that means they belongs to the set S, then what will happen? Is it clear or not? In the case of subset of R, similarly here also you can write, okay? Same thing, whatever you have studied for the subset of R, it can be also written for the sequence also, and we'll see later on, okay, if you want to prove something. So till now you have any doubt?
ఇయ్యి
Just
మామూలుగా
Kosik. So till now you have any doubt?
Sir, the last question of the last class, so that if a sequence even converges to you, and then sir, please explain that one you were explaining, sir.
Yeah, so you have doubt there. What is your doubt? That if un is a sequence of real number converges to u, that is given, right?
Yes, sir.
Then you can show that this mod u sequence will goes to mod u, right? This one you have doubt, Yuvraj?
Yes, sir. Sir, I wanted to know the complete question. Sir, I wanted to know the complete question, sir.
You wanted to know?
The complete question, sir. I couldn't note the.
Okay,
question.
so but in the first class we have write some properties, right? For absolute value function, that mod x minus mod y, and their mod is lesser equals to mod of x minus y. So using triangle inequality, you can prove this, right? Using triangle inequality, what do we mean by triangle? That mod of x plus y lesser equals to mod x plus mod y. Using this inequality, you can prove this inequality. Once you have proved this, then you have to use it here. That mod of un minus mod of u whole mod lesser equals to un minus u. Is it clear? Now, given that this un minus, given that, what is given? That un goes to u. This is given, right? Since un converges to u, so given any epsilon positive, there exists a natural number n, right? Suppose n naught, such that for all n greater equals to n naught, what will happen? This un minus u is less than epsilon, is not it? This is clear. So now you can put it here. So what will get for any arbitrary epsilon? You will get un minus u less than epsilon, right? So for same n naught, and epsilon is arbitrary, so there exists n naught also. In this case also you are getting this. So mod of un converges to mod of u. Then I told whether the converse holds, right? And what is the answer? That converse does not hold. And we have taken the example if we take un equals to minus 1 to the power n. Is it clear? Is it clear or not?
Yes, sir.
Okay. Any other doubt? If you have any other doubt, let me know. So you have seen that this example is giving many various test statement, right? One of them is here you have seen this example you have seen somewhere else. Where? Can anyone recall? Say example will work for some other.
So bounded
Converse.
but not converging.
Yes, so bounded but not convergent.
इसको ऐसे संभाल संभाल के रखना और 2 साल बाद कोई ऐसे रैंडम बता के ऐसे
अरे
बस
कौन है
एक
रे
ऐसा
वो
लगा
प्लीज अभिजीत विश्वास what are you doing? So how we know that this sequence does not converge? This minus 1 to the power n, how we know that this sequence does not converge? Can anyone give some answer? How we know that this sequence does not converge?
There are an odd and even values of n8 against different values.
Huh? How we know that this sequence does not converge?
Sir, it is upper bound by 1 and lower bound by -1, but sir, it values to not converging.
No, I have understood your that upper bound, lower bound. And what else you said?
Sir, it is not attaining a particular value.
Yeah, so you can say that, but that you have to prove, right? That you have to prove that it is not approaching a unique real number here, right? Because you have seen from the definition. Who is Vishnu? So I am marking the role name, okay? So an minus l. So this l is, what is the limit property? That this l is unique, right? If it exists, then l should be unique, right? If the limit exists, then l should be unique. Okay. And what about the minus 1 to the power n sequence? How it some look like? Minus 1, 1, minus 1, 1, like that, right? So where it should converge? If it converges to suppose some real number, then you should get a contradiction. Have you tried? Suppose you guess that minus 1 to the power n converges to suppose minus 1, suppose converges to 1, then you should get a contradiction. So that you should try. Okay, how you'll get the contradiction. So if you have any difficulty, you can ask tomorrow in the tutorial class. Okay. So
Okay,
if
sir.
you suppose that minus 1 to the power n converges to minus 1, then you should get a contradiction. Suppose you say that minus 1 to the power n then converges to any real number l, then also you should get a contradiction. Because what do you mean by that n? Because tail of the sequence should converges to L. That means all the elements of that sequence will lies in the neighborhood of this one. Tail of the sequence should lie in this neighborhood, right? In order to converge to the sequence to the real number L, all the elements of an for some n on n not onwards should lies in this neighborhood epsilon neighborhood of L. Okay. But you will see that if you consider all the elements will not lie in any real number neighborhood, right? Suppose you take L minus 1, then you'll also get some in, if you consider some neighborhood of minus 1, it does not include all the members of AN, right? Is it true or not? Everybody, if you have any doubt, please let me know whether it is clear to all of you or not. Is it clear to all of you? If you consider that L equals to suppose minus 1, 1 or any other real number, then you should get a contradiction, and contradiction should lie like that. That if n converges to some unique real number L, then all the elements of an for some n not onwards should lies in this epsilon neighborhood of L. But this is not true here because elements are minus 1, next is minus 1. If you consider any L, then elements will not lies in the neighborhood of L. That you can get from here, right? You can see. It is clear, all of you? Later on, we'll see some different proof, but this is just via definition, your definition, that epsilon n definition. So this is only using epsilon n definition. That should be clear to you, the definition. In limit also, limit of function will also epsilon delta definition. In continuity also limit in continuity, this same epsilon delta definition should be clear to you. Okay. Any other doubt? So till now we have seen some algebraic properties of sequence so that we can prove convergence, right? Whether the sequence and using epsilon delta. But there are also other properties. Okay, through that you can prove what the sequence will converge. Okay, so let me write on. Suppose UN is a sequence of positive real number. Limit n tends to infinity. Un plus 1 by un is L. Okay. Now if 0 lesser equals to L less than 1, then limit n tends to infinity, un equals to, can anyone guess? Can anyone guess? Can anyone guess? Till now, whatever you have studied from there. What should I write? In the first case, this will be 0 and here it will be divergent. What do you mean by divergent? That means goes to infinity as n tends to infinity. This theorem is clear. So to check where some sequence UN converges. So you can use this theorem. What does this theorem tell? UN is a sequence of positive real number such that limit n tends to infinity UN by UN equals to L. And got L lies between 0 and strictly less than 1. Okay. So here it can be 0 also. So then limit should be, if L is greater than 1, then the sequence diverges. If L equals to 1, then it may converge, may not converge. Okay. Suppose UN equals to 1 by, okay, and you want to use this theorem. then what will happen for this sequence? Can anyone tell me? What is L here?
One by n.
L. What is L here?
One by n.
What is L?
Not defined, sir.
No. What is L?
One
You
by
have to-
one, sir. One by n.
Sir, n tends to infinity here.
Limit n tends to infinity, un plus 1 by un. That you have to calculate. So what is L?
Sir, 1.
1. So L is 1, but the sequence is L is 1, right?
So convergent is 0.
Huh?
Sequence is convergent.
Yeah, sequence is convergent, right? But in this case, the limit un is 0, right? Is not it? So the limit L is 1 here, but the sequence converges. Okay?
Yes, sir.
So whenever some sequence is there, you can check whether the limit is strictly less than 1 and greater equals to 0 or not. If it is there, you can say that the sequence converges to 0. And if it is greater than 1, the sequence diverges. But if it is L equals to 1, then it may converge, it may not converge. We don't know. Okay? Then you have to check some other definition. Is it clear or not?
Sir,
Hmm?
sir, in third point, you write that if L equals to 1, that then is no conclusion.
Hmm.
Why, sir? If L equals to 1, then un tend to infinity.
Huh?
Sir, if un tends to infinity, then L also become 1.
This one?
Sir, third.
हाँ third is what
आपने
is
लिखा है
happening. हाँ मैंने लिखा है कि if L equals to 1, then we cannot
हाँ
get
सर
any conclusion about the nature of the
सर
sequence. Okay?
सर अगर un सर इन्फिनिटी को टेंड करेगा तभी तो L बराबर 1 आएगा.
देखो ये तुम्हारा ये कंडीशन का मीनिंग क्या है. सपोज ये तुम्हें मिला है, अभी बता रहा है if L is strictly less than 1, then this. That means ये sufficient condition है ना. ये जो condition है ये sufficient है. If this holds, then we will say the limit sequence converges to 0. If L is greater than 1, then sequence divergence. And if L equals to 1, then we cannot say anything about the sequence. It may be, it may not be. We don't know. We have to check other different other properties of the sequence. Now, what is your question?
Yes.
That in this sequence L is 1 and the sequence diverges to infinity, you are saying, or what? What is your question?
Sir, I think that sir, if L equals to 1, then that sequence that you write ऊपर जो ऊपर हमने जो sequence लिखा है un plus 1 अपन oh sorry सर मेरे को लगा un plus 1 है वो अलग सा.
No. If the sequence is un equals to 1 by n, then you can check here, right? What will be the limit? N tends to infinity, un plus 1 by un. What will be that? Is not it?
हाँ yes sir.
So limit n
हाँ सर वो
tends to
मैंने गलत
infinity.
समझा था.
Okay, this one, right? And this goes
Yes
to
sir, yes.
this equals to 1, right?
1 yes sir.
Yes. So when
Yes
L equals to 1, this sequence converges, right? To 1 equals to 1. But you know that this sequence converges to 0. So another example, Okay. Can you give some another example where you can say that the sequence does not converge, diverges, but L is 1? Can you give some example of that? It's very easy. Can you give some example of the sequence which
Sir, n is square
diverge?
plus 1 by n.
Huh?
N is square plus 1 by n.
N?
N is square plus 1 by n.
You don't need to, just simple example.
N.
Hmm?
Un equal to n.
Yes, un equals to n, right? Then what will be the limit? What will be the limit? What will be its limit? 1, right? So the L is here, but the sequence diverges. That is the example here about the theorem. So what does one tell? That if un is a sequence of positive real number such that limitation un plus 1 by equals to L. Now you have to check what is the value of L. Whether it is 1, then we cannot say any conclusion because we have seen two examples, right? Both cases L equals to 1, but one of them you know that converges, another one you know diverges. That is written in the case 3. No specific conclusion about the nature of the sequence. But if 0 less than L less than 1, then you will say that un converges to 0. And if L is greater than 1, this sequence diverges. Is it clear now? Is it clear or not?
Yes,
So there
sir,
is
clear.
Yes, sir.
okay. So there is another theorem that suppose un sequence of positive real number and limit n tends to infinity un to the power 1 by n equals to L. Then what? Similarly, can anyone guess? Similarly, what you can say? Only 2-3 people are giving answer. What about other one? Alok Yadav,
Yes, sir.
can you give? Similarly, what should I conclude here? Similarly, if
Sir, L greater than 0 and less than 1.
then un converges to
1.
then un converges to
1.
1 क्यों? पहले क्या था?
0.
0.
0. Hmm.
If L is greater than 1,
L
then
greater than 1. Limit n tends to infinity.
un tends to infinity, right? As n
Infinity.
tends to infinity, it diverges.
Yes, sir.
Similarly,
Divergent.
if L equals to 1,
L equals to 1.
then
Sir, no conclusion.
No conclusion.
About the nature of the sequence. Okay.
Yes, sir.
Is it clear? So can you give some example? You can check. Okay. Can you check? Similarly, so maybe in tutorial I'll send you, and there you will see many sequence, and suppose you have to test via these two theorems whether the sequence converges or not, that you can check using these two theorems. Okay. So suppose this sequence is convergent, I will prove it. this sequence is convergent or not? How will prove it? What are the to check convergence of the sequence? Any theorem, any other theorem do you know? In the last class we have studied. What is that theorem? Last class you have studied. One theorem you have studied where monotonicity is also used. No, monotonicity definition is also used. If a sequence is monotonically increasing and बताओ and
Monotonically decreasing.
No, if a sequence is monotonically increasing and
Bounded above, it is
and
convergent.
bounded above, then
It is convergent.
Convergent.
So
But this sequence is convergent.
yes, this sequence is convergent, and how will prove it? Using that theorem, okay. So first you have to show that this, suppose a is 1 plus 1 by n to the power n. So this sequence monotonically increasing. That first you have to show. This sequence is monotonically increasing. How you show this is monotonically increasing? So can anyone guess?
Sir, an plus 1 greater than or equal to an.
How will show it? That means you have to show this. So how will show this? Whatever you have studied in your 12th class, from there, can you recall properties inequality? Huh? What is that? So that means you have to show you want to show this. Can anyone show this? I'll show this. What kind of property you have to use? Show this, right? क्या consider? Huh? You have to show this, right? So what you have to consider? So, Sohan, are you there, Sohan?
Sir, Aman has wrote AM GM inequality.
Yes. So don't write in the chat box, okay? Because I am not looking at the chat all the time, okay? So just unmute yourself and tell. Yes, so here AM greater than equals to GM. This kind of inequality. For which numbers you have to use? What are the numbers? What are the numbers? So this is n times total. Okay? Can you use it? So what will get in the left hand? So these are the n+1 numbers. Okay. 1 plus 1 by n times and 1. Now if you use, what will you get? 1 plus 1 by n, right? Plus 1 by divided by n plus 1. That should be greater equals to, what should I write for GM? What should I write for GM? Like that, right? Into 1 is there. Is it clear? This you will get, right? Is it clear to all of you or not?
Yes, sir. Clear.
So what will get here? What will get? N plus 1 plus 1 by n plus 1, right? Greater equals to 1 plus 1 by n. Is not it? So that means
1 plus
1 plus 1 by n plus 1.
Okay.
Okay. So what are other properties? So n monotonically increasing, is not it? What about other properties? I will prove this. How you know that this sequence will be bounded above?
Yes, sir.
And by the way, can you recall where it should converge? This you have seen already.
Yes, sir. It's value 1.
Huh? E.
E, E value.
So we'll see later on. But first you have to show that this sequence converges, right? What is remaining to show? What is remaining?
Upper bounded.
That is bounded above, that you have to show, right?
Yes, sir.
How will show that this sequence is bounded above? How will show that this sequence is bounded above? What is your UN? This AN, right? What I have written, AN. Now if you expand, what will get? Yes. What will? If you expand it, what will get?
n plus 1.
1 plus
1 plus 1.
then means I should write like this.
Yes, sir.
Or not?
Yes, sir.
1 plus 1 is also. Next term?
Plus n into n minus 1 into.
Like that way? What about the last term?
Last one is 1 by n की power होगा.
N into n minus 1 into 1, right? This one, or is it okay? Now how will arrange these numbers? How will
जरा
arrange these
ये
numbers?
वजन पड़ जाएगा और चला जाएगा पागल।
Huh? How will arrange this number now? This term how will write? So you need to write like lesser equals to some values that you want to show, right? It is bounded above, right? So you have to show it. Since it is monotone, next property is that it is bounded above, so that it will converge. How will show that? So bounded above by what value? This will be bounded above by what value? No, right? That will converge just to E. So it should be bounded by huh? It should be bounded above by. So what we are doing here, we are dividing 2n for 1n here 1n. Similarly, each n everywhere, right? So we'll get 1 into 1 minus 1 by n, 1 minus 2 by n, like that. Okay. Clear?
for bound.
Huh? Is it clear? So here 3 to 1 is there if you have confusion. So now n should bounded by which value?
2.
Not 2. That is,
One.
if it converges to E, then how can it be bounded above by 1? Already here 2 is there, right? These two term is there, right? To get here we need a right? So what will be the value? So here you have inequality. So that you can show ultimately that this is then 3. Okay. Do you know what you have to use? Your exercise. So tomorrow is the T class. So please complete it, huh?
Sir, from where we get our problem? Which topic is this?
Huh?
Sir, from where we get problems with this topic?
Oh yeah, I'll send you. This is like till now only 4 lecture has been completed, right? But I'll send you tutorial. I'll send very early. But since this is your starting week, okay, enough class has not been completed, right? So only you are asking class till now, right? But tomorrow tutorial. So if you have any difficulties in any problem, then you can ask. Okay. So you have any? So you have to okay where it converts. So you know that this sequence will converge to. So you only need to remain to show that this is bounded 3. That you have to show. Okay. So one another one is 1 plus. Suppose this is the sequence, okay? To converge or not? Huh?
Yes, sir, convergent. Yes, sir, convergent.
How you are you sure or How you are guessing? So here n is your 1 plus half plus 1 by 3 up to 1 by n. Right? So this sequence will converge or diverge? So this is also your one exercise, okay? But you can guess it. At least monotonically increasing or decreasing, that you can tell me now. Bounded above or below or unbounded, that maybe you need some time. But you can definitely say, right? What whether this is greater or not. That you can check. How will you check? You can instruction, right? Now we have positive or negative, right? Is it clear or not? Is it clear? Huh? Decreasing? Huh? What is the difference of a plus 1 minus an here?
If we take n equals to 1, then we get
No, for any n. What will be the difference of these two consecutive terms, an plus minus an? What will be it?
1 by n plus 1, sir.
So this is positive or negative? This value is positive or negative?
Positive.
So positive, right?
Positive.
So n plus 1 minus n is positive. So n plus an sequence is increasing. What?
Increasing.
Yes.
Sir.
In fact, it is strictly monotonically increasing. I mean by strictly, the strict inequality hold. Okay. If you get strict inequality. Okay, you have another class, right? So we'll continue tomorrow. Tomorrow you have tutorial. Okay. See you there.
Record.